So in terms of what we're doing as a company is we're developing a hydrogen fuel cell power plant for aviation. But one of the things that the space program taught me is that you don't go off and land the world's most sophisticated rover on the surface of Mars without having ever done it before. You actually work up in your capability in terms of mass, in terms of complexity, so that you can get to better and better missions downstream. So for reference, the space program, the Mars exploration program has been going on since the 1970s, but we've been able to perfect our landing techniques over the course of time by doing this incremental approach to get us to where we are today, which is landing really big payloads and ultimately people next. So you can do the same thing with aviation. So if you start with smaller aircraft and get those into production, get those into use, you can actually get the technology into the marketplace. You can drive demand, another end use for hydrogen, which drives more green electricity production. And you can get people flying for a range of use cases, which can include things like general aviation, flight training, vertical lift, urban air mobility, air taxis, cargo transport, and even low capacity regional transport. And our company is actually funded by the United States Air Force as part of the Agility Prime program, because there's a whole range of use cases in the humanitarian aid disaster relief front, which already use smaller platforms. So you don't have to solve the jet aircraft problem first. You can solve all these other aviation use cases first and use that to advance the technology into these larger platforms in future. So who is our team? So we are a team of several of us are rocket scientists. We work for NASA on the development of launch vehicles. We work for Boeing on launch vehicles. We work for Blue Origin. We work for SpaceX. But we also worked on electric aviation at Boeing. And we also work in a variety of different electric vehicle automotive companies, because it really does take that combining of skill sets across these different sectors to be able to bring about this new product, this new technology into the aviation marketplace. And we're also have a company who have tons and tons of interns. So this is a huge opportunity for universities to have a whole new training program in the area of hydrogen electric propulsion systems, which is chemical engineers, material scientists, mechanical engineers, aerospace engineers, electrical engineers. It's kind of exciting how this is a tremendous opportunity across the board when you think about this new space. And our product is a 200 kilowatt power plant, which can fit inside existing single engine aircraft. That's our first implementation. And so our design requirement, of course, per the talk on the very first day of the conference, is that you have to match the utility and you have to match the cost of the incumbent, which is what we do. So our system as designed provides the same endurance, provides the same payload capacity, and fits within the limitations of a suite of aircraft that are at this 200 kilowatt power point. And that way we can promote adoption. That way we can get the product into the marketplace. And that way we can get people flying emission free. And the real challenge behind hydrogen propulsion is how you store the hydrogen, because naturally it's standard temperature and pressure. It is a low density gas. So you have to either store it as a high pressure gas, which is how it's done for the automotive application. I actually drive a hydrogen fuel cell car myself because we have hydrogen infrastructure in California, or it has to be stored in liquid form for the aviation application to give you the range and the payload that you're looking for. And just to go a little bit deeper into how one optimizes this technology, we're a company of engineers, so we're always looking for sensitivities in the system. And whenever you're designing a new power plant for any transportation use case, you have to look at the combination of cost, unit cost, cost of ownership, the combination of weight. How do I make this thing weigh as little as possible, which maximizes payload capacity, and then durability. And durability is key to the aviation use case because nothing requires higher reliability and safety than an aircraft does. So you have to focus on design for durability, which leads to reliability, leads actually to a reduction in weight because you're operating more efficiently, which also can lead to a reduction in cost because you're operating more efficiently at the end of the day. And so we do that through a suite of new technologies, from a new membrane to new catalyst material, as well as a lightweighted design of our stack and balance of plant components, which ultimately gives us better specific energy, electrochemical efficiency.